Okay, so we have a quiz here, and I'm going to work through it rather quickly because everybody did pretty well. Okay, 2/3 plus 3/4 equals what? Well, your common denominator is 12, right? So common denominator is 12. We'll make a note of that, and we're just going to work it like this. And we have 2/3 plus 3/4, and we multiply the 3 by 4 in order to get 12. So we're going to multiply by 4, and then we have to multiply by 4 up here, because we multiply by anything except 1, we change it. We're going to change the way it looks, but we're not going to change its value. And then we're here, we're going to do this. And I think everybody knows that's what you do, but you want to write it out that way. Okay, because if you get something with a bunch of symbols in it, you're going to have to be very meticulous because it's going to be confusing. And you want to make sure you understand that step and write it out. Also, you want to write the thing out coherently rather than write this here and write something over there. If you do scratch calculations off to the right and do your work in a nice column on the left, so you can always follow it. Because if you go back to review it, and this is especially true for your homework, if you go back to review it and everything's scattered all over the page, you're going to tear that page out and burn it. Okay, don't want to do that. Yeah. So write it out as coherently as you can, because that clarifies your thinking, makes your thinking clear. So anyhow, those could be wrote to 1 and 5/12. That's okay. Usually, we don't bother writing the mixed number, but you need to be able to do it. For example, if you want to locate this as a point on the x-axis, 17/12 is a lot harder to locate than 1 and 5/12. Okay, you know it's between 1 and 2 if you write it like this. And then a little less than halfway, so you put it about where it belongs. Make sense? Okay. Okay, now we got 5/8 plus 7/3 equals. So they put the note here, your common denominator is what? Well, it's 24. Okay. Always, you can use this times this as your common denominator. Now, if they have a common factor, you could use a smaller common denominator. So we're going to multiply by 3/3 here. That'll give us a denominator of 24. The 7/3, we're going to multiply by 8/8. And that's going to give us 15/24 plus 56/24, which, if I'm doing it right, is 71/24. And then if you want to locate that on a coordinate axis, that's going to be 2 23/24. Now, to do that right, it's 15, that's 56, that adds up to 71, yeah. Okay. Okay, then what's 2 to the 4th? Should be working over here, so I don't block them as much. 2 to the 4th means I'm debating whether to write out the whole thing. I'm going to write it out. I can group it any way I want. I'll group it this way, which is 4 times 4, which is 16. Everybody knows it's 16. Everybody got that. It's not a problem. Now let's talk about our friends, the negative exponents. This is the thing that people often miss. Okay. Don't seem to understand it, and we'll see why it's true in a minute. 3 to the negative 2 means 1/3 squared. Okay, and that's going to be real important for some of our graphs. Okay, like some of the ones you've already constructed. Just we haven't put numbers on them. We're going to do that later today in for calculus class. Okay. So that's 1/9. So that's pretty easy if you remember the rule. Okay, now I'm going to skip down to x to the negative third times x to the third. Since everybody was real good with the rules of exponents, everybody got this one and got this one. Well, I'll write them out. X to the negative third times x to the third, really a rule of exponents, and you would want to, I'll do this in column, you'd want to do this applying the rule. It's x to the negative 3 plus 3, okay? Which is x to the 0. Now, show me with the fingers in your hands, what is x to the 0? Okay, don't make that mistake, okay? That's 1. Not 0. Okay? It would make no sense for it to be 0. Now, the reason is why? X to the negative third times x to the third is 1 over x to the third multiplied by x to the third. 1 over x to the third times x to the third. If you want to, you can put a 1 here. When you multiply fractions, you multiply the numerators, you multiply the denominators. Multiplying fractions is very easy. Adding fractions is a little more challenging. Okay. So if I do that, I get x to the third over x to the third. And when I divide something by itself, I get 1. Okay. That's one of the reasons why we say that x to the 0 has to be 1. Now there's some subtleties to what are assumptions and what are consequences of the assumptions. Okay, that you don't need to worry about in this course. Okay, it's a little bit subtle. We don't pay too much attention to it. Okay, now x squared times x cubed. Now, if I ask you to write this out in detail, there's your x squared. And we got 5 of them. Okay. That's by without using any rules. Okay. Now, by rules, okay. And I want to see that stuff. Even though everybody got it, and I'm sure that's what they did. I mean, you might have counted the x's in your fingers. Let's see, there's 1, 2, and 3. That's 5. I don't think you did that. It's much easier to just add the exponents. Okay. And if you counted them in your fingers, that's good too. Okay. Not going to be so good if I ask you to do x to the 48th plus x to the 365th. You don't have that many figures. Okay. And you don't want to write them all out. But you can see what the pattern is very easily. Just how many of these are there, how many of these are there. That's how many you have if you put it like in this term. And I think you understand that, because again, everybody got that. Okay. And then x squared cubed. Well, if we just do that by what the exponents say, we're going to have x squared times x squared times x squared, which equals x times x times x times x times x times x. Well, that's x to the 6th, because we can remove those parentheses. The sequence of multiplications can be done in any order. We could do what we did here. We could group them in pairs or whatever. and then group them again and everything, but it'll work out. Okay, so that's all I'm gonna say about fractions. I think you're in pretty good shape here. But make sure the details and make sure you know how to write these out. I would go back and just write out half a dozen of them. Won't take you 10 minutes. Okay? Just to get used to writing them out and to reinforce what we just said. Okay. And we're going to start with the idea of domain, domain and range, starting with the idea of domain. Two things with the domain. Can restrict the domain has to be restricted by what you can't do. Okay. So if I ask you to divide by 0, you can't divide by 0. It's undefined. Does not exist. Okay. And we can see that very clearly in terms of the reciprocal graph that you've constructed, you learned to construct. Then I talked about it some. It's like when I said, you go twice as close, you go twice as far from the horizontal line in the middle. You go twice as close again, you go twice as far as that. You go twice as close, you go twice as far as that. And pretty soon, you're all the way on the other side of the earth. Okay? And you never get to 0. It makes no sense to divide by 0. Another way to say that is, if I ask you to divide by thirds, how many thirds does it take to make 1? It takes 3 of them. How many tenths does it take to make 1? It takes 10 of them. How many billionths does it take to make 1? Show me with your fingers. Well, yeah, because sometimes I get the wrong finger when I ask that question. Okay, so you know, that's you can't do that. Okay. But you know it'd be a billion. Okay. There's no limit to how big numbers get when you divide by them. Okay, if you divide 1 by any number, no matter how big. Well, if you divide 1 by a really big number, you get a really big number. And if you want to get a bigger number, you divide it by an even bigger number. Okay, so can't divide by 0. And I said everything. I'm not going to write out the reasons. We will talk about them because people will screw that up. People want to divide by 0 and get 0. Okay. Another way to understand dividing by zeros is how many zeros does it take to make 1? You can count the 1 by third, 1/3, 2/3, 1. Count the 1 by tenths, 1/10, 2/10, 3/10, up to 10/10, which is 1. Okay. Now try to count the 1 by zeros. 0, 0, 0, 0, 0. You never get anywhere. It's not, doesn't make sense. Okay. So you can't divide by 0. You can't take the square root of a negative. Why not? Well, what's the square root of 25? Can you tell me what the square root of 25 is? Go ahead and finish writing. Then hold up the right number of fingers. If you don't know, I'll explain further. It's 5. Yeah. It's 5 times 5 is 25, right? Okay. Now, what would you say the square root of negative 25 is? Now, you'd be tempted to say negative 5, but what's negative 5 times negative 5? 25. It's not negative 25. Okay. So when you square a negative, well, because squares can't be negative. If you square a negative number, you get a positive number. So if you wanted to do the square root of something that's negative, you'd never find a number. You multiply by itself to give you a negative. Since two numbers can't, the square of a number can't be negative, you can't do the square root of a negative. Square rooting is just the inverse operation of square. Okay, so make sure you kind of understand that, because those are the two biggest things that you run into when you're restricting a domain. Okay, so let's just take a few examples. Let's say you have a function. I have introduced function notation, even though I haven't assigned it. Let's say you have y equals f of x equals square root of x minus 7. Okay. Give me a number that would work in there, a number for x. You do it with your fingers if you use enough of them. Is that 11? No. That's 8. Okay. Well, you see, you did something quick, and then you held up one finger. So I didn't know what you were talking about. And I didn't see that you only held 3 fingers. I didn't think you had all 5. So I asked. Okay, 11. Okay. If I do 11 minus 7, I get 6, 8, 4. Right? I get 4. And the square root of 4 is 2. Okay. So x could be 11. That works out just fine, doesn't it? F of x, if x is 11, becomes f of 11. Then if x becomes 11, this x becomes 11, so you get the square root of 11 minus 7. Square root of 4 is 2. Okay, so you went and chose a good number there, one that we could actually write the square root of. X could be 10. F of x equals f of 10 equals the square root of 10 minus 7, which is the square root of 3. That's about 1.732, as everybody knows. There was a time when everybody did know that, because we didn't have calculators and we came up on it. Okay. But you can do the square root of 3. Okay. Like if you square 1.7, you get 2.89, which is less than 3. If you square 1.8, you get 3.24, which is more than 3. So you've got the square root of 3 squeezed between 1.7 and 1.8. Okay. Then if you square 1.79 or 1.73 or 1.74, you'll find that you've squeezed it that much tighter. And there's no limit. You can keep squeezing it forever, because it just goes on forever with no pattern that we can discern. Okay. Called an irrational number. Okay. Okay, what can't X be? Give me a number that X can't be. Is that 9? X could be 9. 9 minus 7 is 2, and the square root of 2 is a perfectly good number. Okay, but X can't be 4. Okay, why can't X be 4? Square root of -3, right? So you can't. Four is not in the domain. It wasn't able to write that as clearly as I like to looking for. Okay. Now, what's the restriction? What's the biggest number that's, what's the smallest number that will be in the domain? Can you show me? You do a smaller one. Okay, both saying 9, okay? 9 is in the domain. Okay, what about 8? Yeah. Out of 1, there you get 1, right? Square root of 1 is 1. Okay, what about 7? What do you get? You get 0, right? Well, is there a number you could square to get 0? Yeah, square 0. Okay, so X could be as small as 7. Okay. X could be 9 or 8 or 7. Is the square root of 9 minus 7 is the square root of 2. That's okay. Square root of not 8, 7 minus 7 is the square root of 1, which is equal 1. That's certainly okay. And the square root of 7 minus 7 is square root of 0, which is 0, and that's okay. Again, square root of 0 is 0 because 0 times 0 equals 0. Okay, makes sense? All right. Now, if you go any lower than 7, though, you're going to get a negative number, right? X is less than 7, then X minus 7 is negative. Then you get a square root of a negative. Okay. So the condition. We can go to little algebra. The domain of f of x squared of x minus 7 is all values of x such that x minus 7 is greater than or equal to 0, because you can take the square root of any number that's greater than or equal to 0. And you can solve this. If you add 7 to both sides, minus 7 7 gives you 0, so you get x. And you get x greater than or equal to 7. Okay, and I just realized that last reading bit of stuff that I wrote wasn't there, and that's pretty easy to understand. I just said x can't be 8, 9, or 7. Because square root of 9 minus 7 is square root of 2, square root of 8 minus 7, and square root of 7 minus 7. All gives you numbers you can take the square root of. Again, 0 times 0 equals 0, so the square root of 0 is 0. What x can't be is less than 7, because then you get the square root of a negative. And then the domain of f of x equals square root of x minus 7. And I say is, and this we want to say very clearly, it's all values of x that make this greater than or equal to 0. Because that's your condition. Whatever's under the radical has to be greater than or equal to 0. Okay. So you can write that out as an inequality. And if the expression is simple enough, you can solve that inequality, right? So you get x minus 7 greater than or equal to 0, and that's easy to solve. You can add 7 to both sides. And there you got it. Okay. Okay, so what would you write down? The domain of this function. Now, what you don't want to do, I need to move this camera over just a little. Okay, well, there's our function. F of x equals the square root of 5x minus 19. You don't want to, you can play around with numbers. Okay, and you can eventually probably figure out what the number would be just by trial and error. Okay, like if x equals 4, that's going to give you 20 minus 19 square root of 1, right? So the smallest x will probably be just a little less than 4. And you might be able to figure out what it is, okay? If, you know, it's a fraction, but you're not going to bother with that if you know that you can just do this. Okay, so what inequality would you write? See if you can write that inequality and solve it. Okay, now what most people did here was, some people just said, okay, you divide 19 by 5. Okay, and you get 3 4/5. Now, everybody got a little confused on doing the long division. Okay, and some more than others, but that's okay. That's really easy to do. Okay, so you could go directly to that, and that's good. You knew what the number would be. Okay, so that's great. But look what I did here. I wrote an inequality. Okay, and that's what you really want to do, because if it was the square root of ax minus b, you wouldn't have numbers to divide. We'll do that one in a minute. Okay, but so this would be all x, for which we usually say such that, but for which works just as fine. Okay, so you can see it either way, for which 5x minus 19 is greater than or equal to 0. To solve this, 5x minus 19 plus 19 would be greater than or equal to 0 plus 19. We just add 19 to both sides. Okay. And negative 19 and 19 is just 0, so we get 5x is greater than 19. And now we want to solve for x. Do it with an inequality. We just divide both sides by the same number. You know, made it an equality here. Okay, now the only catch is, and you get this, we'll talk about this, but you do want to know the rule. If you divide by a negative number, you got to reverse an inequality. You'll see examples like that. Okay. You should read your text. And so that x is greater than or equal to 19/5. Okay. Now what's 19/5? Well, it's a little less than 4. You do that. Well, you can do long division. I can't use 4 here because it'd be more than 19, but you get 4. Okay. And then if you divide 5 into 4, we get 4 divided by 5, which is 4/5. Okay. You remember now. Just to refresh you, because you probably haven't had to do much long division. Now we get into long division of polynomials, which is not that hard, but you do kind of want to remember your long division algorithm. Okay. Because what we do with polynomials is so simple. It looks weird, but it's really not any hard. In some ways, it's easier. Okay, so let's go ahead and do. The domain of square root of ax plus b. You can see what I wrote down here. It's right here in the floor. Okay, now the square root of ax plus b, and let's give that a name. Call that f of x. Ax plus b greater than or equal to all x. And you want to write those words out when you do these to reinforce the logic of what you're doing. Otherwise, you're just writing down symbols and you won't necessarily understand them as well. You reinforce the idea every time you write it out. And you want to think every time you write it out. So you do, okay, well, ax plus b minus b would be greater than 0 minus b. So that ax is greater than negative b. Everybody got that step. Okay. No? Yeah. Now you're going to want to get x, so you're going to divide by a. So that x would be greater than equal to negative b over a. Now that looks like it's a negative number, right? I mean, you got a negative sign there. Of course, you don't know a and b could be positive or negative. You got to be careful about whether a and b are positive or negative. I say provided. Well, I could just say this. If A and B are both positive, negative B over A is negative. Okay. If A and B were both negative, it would still be negative, right? But if they have different signs, then negative A over B or negative B over A would be a positive number, right? Okay, one of them's positive, one of them's negative. So you gotta be a little bit careful and make sure that this result makes sense. Various values of A and B. Now, I'm not gonna go into the details of that, but that's something you just want to think a little bit about, and you might well encounter. Not sure that you encounter in this assignment, but you might. Okay. But the main reason I wanted to introduce this is simply now you're doing it with symbols, and you're not sure what the symbols mean. Maybe they're both positive, maybe one's positive, one's negative, maybe they're both negative. Okay. Okay. Now there's another case. What if you had x plus 8 over x minus 3? What would restrict your domain? What numbers could you not use here? Okay, so as I said, your domain is restricted. You can't divide by 0. Can't take the square root of a negative. There are no square roots, so you don't have to worry about that. But you might have to worry about dividing by 0 because you got a denominator here, right? Okay. So the denominator can't be 0. So you could write x minus 3 not equal to 0. Okay. Now you don't have to write out this equation in this case. Or you could just set this thing equal to 0 and say you can't do that, right? Or you can just look and say, oh, x can't be 3. Okay. And just looking is okay. You have to know that you could write it out like this. And then x minus 3 plus 3 cannot be 0 plus 3. So x can't be 3. Main is all real numbers except 3. Now, open math will want you to write something like this out in interval notation. And it's going to look like this. And I'm going to let open math explain that to you. I'm not going to go into much detail, I'm just going to say it, but it'll show you. And if it happens not to, we'll go over it. But I don't think you're going to have any trouble. This just means the interval from negative infinity to 3, not including 3. That round parenthesis there means you're not including 3. So that's all numbers from negative infinity up to 3. And then all numbers from 3 up to infinity, where 3 isn't included either way. So that's how you can write this thing excluding 3. It's not something that usually gives people trouble, but sometimes people are getting everything and they just don't understand that interval notation. We'll take care of that if that happens. Okay. So those are examples of domain. We're not going to talk right now about range. That can get a little bit tricky. I'm going to see what you do with it. And then if you're probably gonna have trouble with someone. But when and if you do, we will talk about it after you've given it a try. Okay. So you got to do a little algebra. Don't want to talk about that much algebra right now. Okay. So if you don't get the right parts, I'll probably give you an extension on that part. But try, because your algebra seems pretty much okay. I mean, everybody gets to point with their algebra, just isn't there. Okay. There are all kinds of algebra tricks. Okay. Now, another question. If you're working by the hour, and you make $80 in 4 hours, how much is that per hour? Got that immediately, right? Well, that's a rate of change. Okay. $80 in 4 hours is $80 divided by 4 hours. Now, the change in y divided by the change in x. Now, in the example I just gave you, if delta y is $80, well, that's how much your wealth increased. Okay, how much the money you've accumulated has increased. Okay, maybe you've already accumulated $12,000, but that's $80 more. Okay, that's change in how much you've accumulated, right? They divide that by delta x, which is how long you had to work to do it. Might be better to call that a delta t, and often we do. But since you're used to y and x, we use x. Okay. You earn $80 in 4 hours. We write that as $20 per hour, right? That's a really easy calculation. And I could ask, okay, if you're making $25 an hour and work for 6 hours, how much money do you make? That's easy too, right? That's the easiest one. That's the one you'll always calculate once I tell you how much you're making and how many hours you're going to cut. Okay. And then if I say you're making $30 an hour, how long is it going to take you to make $250? You divide the 250 by the 30, get 8 1/3 hours. Okay. So a little overtime on an 8-hour day. With no extra for overtime, you get to 250. Okay. Okay, makes sense? Pretty simple. Okay. Well, stay that simple. There's no one. $110 degrees at 230. What would you say is the rate average rate of change of the temperature respect to time? Well, how do you start out? Start out the same way I did. Average rate is delta y over delta x. Y is what and x is what? Y is the temperature. So delta y is what? Delta x equals what? Now delta means change, right? Change in. Okay, what everybody did is mostly right. Okay, real good. But the delta y is average is obviously going down, right? Now you take the later minus the earlier. Okay. And if its temperature is going up, then the later would be higher and you'd have a positive, right? But you got to be careful about the signs and the later minus the earlier. Then the later minus the earlier here, well, time is obviously going forward. It's 2.5 hours. You don't want to try to do 2:30 minus 12 o'clock. But, you know, you can get that. Or a minute. Okay. So you could use either. So it's negative 110 degrees over 2.5 hours. And if you divide that out, you get 44 degrees per hour. Or the average rate would be negative, it's not negative 110 degrees, it's negative 60 degrees. Sorry. And that's negative 20 degrees per hour. I did all kinds of things wrong. Trying to get this into time runs out. Okay, so we have negative 50 degrees over 150 minutes, which equals negative 1/3 of a degree per minute. Now, graph of time here and temperature here. I'll use big T for temperature and little t for time. Since I've used y and x, I'll use y and x. That's the future. Okay. The information here is at 12 o'clock, The temperature is 160 degrees. Well, let's let 12 o'clock be right here. That's not really here. And here's your temperature, and it's 160. Now put the degrees here on the y-axis, and I'll put the actually I'm going to put minutes here so I don't have to worry about times. So I'm going to say this is at 0 minutes. And we declare that 0 minutes occurs at 12 o'clock. Then we know that the temperature is 110. The time is 150 minutes. That gives us 2 points on the graph. Okay. And the other thing that you should understand, because we talked about it a little bit last time, is you got your exponential curve, which kind of looks like this, right? And this is a backwards exponential. It's a decreasing exponential. So it's like you've got an exponential. It's approaching some room temperature. We looked at that last time. Okay. And the point I'll make here is if the rate of change is greater here than it is here, temperature is changing faster here than it is here. It's clear from the graph, right? But the average rate of change is just using these 2 points. And you can calculate that average rate of change using this triangle, where this is this is negative 50 degrees. And you calculate the slope of this hypotenuse here. And what's the definition of slope? It's rise divided by run. Rise is negative 50, run is 150. Which is negative 50 degrees over 150 minutes. Which is negative 1/3 degree per minute. Which agrees with the average rate of change. So now we can put our information on a graph, draw a little triangle, and calculate our average rate of change and represent it on a graph where we see that the slope of that graph represents the average rate of change. Now that's a mouthful. That's a lot. Think about that. Okay, you're going to see some of that in the assignment. Okay.